Alright, today we're going to start learning about triangles. We are going to classify them, basically give them a name based on their sides and their angles. You guys should have seen this before, so it shouldn't be brand new. But we're going to talk about the sides first. The sides, they can either be scalene, isosceles, or equilateral. Okay? Scalene triangle has all sides are different. So here we're going to put all sides different. Right? Isosceles triangle has all sides, or two sides the same. So two sides the same length. Alright, so we have two sides are the same length. And equilateral, I misspelled that. Equilateral is all sides are the same. So all sides are same length. Alright, so those are the three ways to classify it by the sides. Let me move that over. We're going to do the angles now. By angles, the same kind of thing. We can have an acute triangle, a right triangle, or an obtuse triangle. Alright, acute triangle has all acute angles. So we have angles are less than 90 degrees. The right triangle has a 90-degree angle. And an obtuse triangle has an angle that's greater than 90 degrees. All right, you guys should have seen that before, so it should not be anything brand new. All right, then the next thing we're going to do is triangle sum theorem. Now, this is kind of confusing, the words behind it, but it's pretty easy. The sum of the measures of interior angles of a triangle is 180 degrees. Alright? All that means is that when you add up all the angles inside of a triangle, for instance, I'm going to tell you this one here is 90. If this one here is 30, then we can kind of add them all up together. So 30 plus 90 plus, and we'll put an X here, equals 180 degrees. Then you can solve for x and you'll get x equals 60. So we're going to do some problems here, very similar to that, and just using that. Now, it doesn't matter if it's a right triangle, as in this guy, or an obtuse triangle, or if it's acute, all the angles on the interior are going to add up to 180 degrees. So here's a problem that you'll see with that. Alright, so we're given this kind of crazy problem. And we're going to go fast on this. If you need to write the equations, and write them down. Alright, but we're going to look inside of a triangle. This triangle here has a 90, a 40. This guy's going to be 50. Now, we're not just using triangles. We're going to use everything that we know. So 3 is a vertical angle. So 3 is also 50 degrees. Angle 2 and angle 3 are a linear pair. So this is 130 degrees. That means this number 4 is 130 degrees. Now inside of this triangle here that I'm highlighting, inside that triangle we have a 90, a 50, and this needs to be a 40. Now, the angle 6 is the last one we need to find. And angle 6 is, we have 20, 130, which is 150, and this guy is going to be 30 degrees. All right, so before you start answering these questions, sometimes it's nice just to fill in all your information in the entire picture, and then you can just kind of go and answer the questions. If it wants angle 1, you just look at it and say angle 1 is 50, so on and so forth. All right, one more thing we're going to talk about today is exterior angle theorem. Okay, so the measure of the exterior angles of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. That's a little confusing, so we're going to break it down. This is my exterior angle there. Okay? So that is my exterior angle. I'm going to put EXT here. Exterior angle. All it's saying is that this angle here is equal to this angle plus this angle. Those two angles there. The non-adjacent, not next to, but the other two angles that are inside of the triangle. All right, so this is pretty easy to see. Let me give you an example, and it makes a lot more sense. Let's just choose easy examples. We'll say this is 50. This is 70. All right, that means 120. That means this guy is going to be 60. Now, that exterior angle is a linear pair with my 60. So we know that this is 120 degrees because they add up to 180. But if you notice, if you take 50 plus 70, they add up to 120 degrees. So we're going to use this theorem as well. All right, and this is the new thing that you guys are learning. The other stuff you should have already seen before. So let's do a problem. All right, we're finding x. In this case, we can do it a couple of different ways, but we know this is 70, this is 30, so x equals 70 plus 30, which is 100 degrees. All right? You could have done all the angles add up to 180, so we have 100. That way this guy is 80, and then it's a linear pair, so it would have to be 100. That's pretty basic just to help you guys see, but one more difficult problem. All right, so here we have two triangles. All right, notice a few things. These are parallel lines. So to me, that means I'm going to start looking for alternate interior, alternate exterior, all that kinds of things. So here, I'm just going to fill in a few things that I know. All right, and then we're going to talk about it. This is 75, so its vertical angle is 75. All right, now what they want you to do here, and you don't have to do this, but you can look at 75 as your exterior angle is equal to 43 plus y and minus 43 on both sides. And you can get y equals, and that'll give you 32. All right, but you don't have to do it that way. It's there, but there's a lot of different ways you can do it. This is 75, so that means this is 105. All right, and then you can do 43 plus 105 is 148. 180 minus 148 is 32. Now to find x, we need to use these parallel lines. So this is 43, this is x. These are alternate interior. Alternate interior angles are congruent. That means their measures are the same. So in this case, x equals 43. Y equals 32. Okay, so there's a lot of different ways to use this. You don't necessarily need to use it all the time, that exterior angle theorem, but maybe you guys will actually use it, maybe not. You can go kind of a lot of different ways on many of these problems.